I'm gonna go over two chapters as an exam review, and as you could tell, it's a lot of ideas and a lot of topics. I came up with 50 questions. To go over 50 questions, I was expecting that's going to be a lengthy video, because usually when I cover one section with more examples, I go like 15 to 25 minutes. But this time it's a different video. It is close to 1 hour and 30 minutes. And it took me a while to type, write, clean up my notes, go back and forth, and record, edit. So hopefully you appreciate it. It's 50 questions. The topics are clear on the screen. It's all about exponents, scientific notation, radicals, rational exponents, polynomials, factoring, rational expressions, and simplifying with factoring. Chapter 2 talks about linear equations, graphing linear equations, two variables, meaning slope and y-intercept, also needs to be known. Finding the equation of a line, giving a slope and a point, or giving 2 points. And the equation of line comes in two forms, slope-intercept form and point-slope form. Quadratic equations, how we factor and solve, and why we factor, which is a principle of zero products. And of course the discriminant sometimes tells me if I have one solution or two or none. Other types of equations. And finally, absolute value inequalities and linear inequalities. In linear inequalities, you have to keep in mind, if you divide by negative both sides, you have to flip the inequality. As I said, it's a lengthy video, so hopefully you appreciate it. Let's get started. 1.1 Real numbers and order of operations will be applied in different examples, but instead of skipping this section, let's go over two properties that you should know. Commutative property for addition and multiplication. The commutative property for the addition will be a plus b equals b plus a. For the multiplication one, similarly, but multiplication instead of addition. A times b equals b times a. The associative property for addition has three elements in it: a plus b plus c, again a plus b plus c. The difference is you could add b plus c first, you could group b and c, or you could group a and b. That's called the associative property for addition. For the multiplication one, it will be a times b times c, again a times b times c. That will give you the same answer if you group b and c first or a and b first. Moving on to section 1.2. is exponents and scientific notation. Simplify for the first question the following expression. Write answers with positive exponents. Since the exponents here are positive and I have a negative exponent right here, I will reduce my steps. Instead of distributing or applying the power of a power, move it down with the concept of a to the power minus m is the same thing as 1 over a to the power positive m. So moving this way, applying it, we will have 2 t to the 5th w to the negative 2 all raised to the power 2. This goes down, so instead of writing 1 over, let's put it down here below. So it's going to be 3 t to the second, w to the third, all to the power positive 3 now. Not negative 3, positive 3, because we're applying this rule. There is another rule that says a times b to the power m is the same thing as a to the power m times b to the power m, which means we're going to apply this inside to each part. So we have two to the second, t to the fifth to the second, w to the negative 2 to the second, over 3 to the third, t to the second, that's this one here, to the third, and w to the third to the third. Third rule that I'm going to apply is a to the power m to the power n is a to the power m times n. That's like m, n, same base, so we could apply this. So we have the following. Let's move it up a little bit. That's a 4. T to the fifth to the second, applying this rule, that's t to the 10, 5 times 2, w to the power negative 2, negative 4. Negative 2 times 2 is negative 4. 3 to the third, 3 times 3 is 9, times 3, 27, times t to the 6, 2 times 3, times w to the third, times, or 3 to the third, which is to the power 9, equals this is negative exponent, so we're going to apply the first rule right here. We're going to bring it down, and these two will simplify using this rule. A to the power m over a to the power n is a to the power m minus n. So we have 4 over 27, that 10 to the power, t to the power 10 over t to the power 6 will be t to the power 10 minus 6, which is t to the power 4 over 1. And this one right here, negative 4 minus 9 is negative 13, but bringing it down will make it to the power positive 13. Instead of subtracting, you could just move it down and add the exponents right here. 9 and 4 is 13. Final answer, 4 over 27, t to the 4 over w to the power 13. That should do it for problem number 1. Let's move on to number 2. Convert to decimal form. One thing about converting from decimal to scientific and from scientific to decimal is sometimes I notice students sometimes they forget moving the decimal to the right, moving the decimal to the left, writing positive exponent, negative exponent. I'll show you what I mean once I finish these 4 problems. I usually use the common sense as I'm doing these problems, and I'll show you what I mean in just a second. Now, I'll start with this one. 5.6 times 10 to the power 2. But 10 to the power 2 is 10 times 10, which is 100. That tells me that this number should get bigger, because I'm speaking about 5.6 multiplied by 100, which means I need to move the decimal to the right 2 places because of the exponent 2. This becomes 5, 6, 0.0. I don't have to show that 0.0, but basically because I'm converting to decimal form, at least I'm showing where I moved it. So it was here, moved to the right 2 places, because it's like I'm multiplying by 100. Done. Well, if you multiply by 10 to the power 2, you move the decimal to the right to make the number looks bigger. If you multiply by -2, you move it to the left. So we're going to move the decimal to the left 2 places. This becomes 8, 9, moving it once, moving it twice. I have to show a 0 right here to show that I moved it twice. Now, let's look at this number, 0.00875. To write it in, to convert to scientific notation, the decimal has to be between 8 and 7, because the number right here has to be less than 10. So, times 10, that's my first step, or my second step after moving the decimal. Then I need to decide about how many times I moved it. Well, I moved it 3 places. The main question right here is, do I write 3 or -3? Well, if I write 3, it's going to look like this, which means I'm multiplying by 1,000. I'm multiplying 8.75 times 1,000, it's going to look bigger like this number. But I need to write negative. When you multiply by powers of 10 with negative, the number looks now smaller. So that agrees with that, which also confirms it. If it's positive, it has to go the other way. Done. This one right here, I need the decimal still between 8 and 7. So 8.75 times 10 to the power 1, 2, 3, 4, 5, 6 to move it here. So before I decide 6 or -6, I need to think. If it's positive 6, it's going to look like a million. If it's -6, it's going to look smaller, so positive 6. Now the comment that I mentioned earlier is the following. Notice right here I moved the decimal to the left, but I wrote positive exponent. I moved the decimal right here to the right, but I wrote negative exponent. Here I have negative exponent, but I moved it left. Negative exponent moving right, negative exponent moving left. That's what confuses some students. My concern, my hint to you is the following. Decide how many times, how many places you moved. That determines the number. Then decide if it's positive or negative. Well, think about it before you decide. 8.75 times 10 to the power 6, positive 6 will make it like this, so positive. 8.73 times 10 to the power -3, negative, not positive, will make it smaller, looks smaller, 0.00875. If this is money, $8.75, and you multiply it by 10 to the power -3, you're not going to have much money left, because that's a small value. Your account, would you rather to multiply by 10 to the power 3 or 10 to the power -3? Well, of course, 10 to the power 3. It's going to make it more clear as money. Times 10 to the power -3 is going to look like less than even a penny. So, differently, you could always think that positive exponents is our 10 system number, placeholders, 10, hundreds, thousands, and so on. When you multiply by 10 to the power -2, you're actually dividing by 1 over 10 to the power 2, which is 1 over 100, which is 0.01. So every time I multiply by negative exponents on top of power, you're dealing with dividing by 10 to the power +2. So that shows the difference between negative exponents value and positive exponents value. So it's almost like you're dividing by. So I think that's good enough for these 4 problems. Let's move on to section 1.3, where it says radicals and rational exponents. To simplify this, the radical expression, notice that 400 is 4 times 100. And square root of 4 is 2, square root of 100 is 10. Or I could do the following. Square root of 400, square root of x to the 4. Square root of 400 is 20. Double check, 20 times 20. 2 zeros, 2 gives you 4, and we're done. This right here will give you x to the second, and no need for absolute value. Done. This right here, I'll give you a hint before we start. When they say simplify, I'm assuming that I could add them. But I can't add them at this moment, because I don't see any like terms. So the hint is the following. This has to speak radical 3. To force it to speak radical 3, let's think inside 75. 75 is 25 times 3. And that will lead me to square root of 75 to be square root of 25 times square root of 3, and that's a 5 square root of 3. That's where the square root of 3 is gonna come in handy when you add them up. Back to the problem. So this is 6 radical 3 plus 7 times 5 radical 3. 6 square root of 3 plus 35 square root of 3. Now I do have square root of 3's, 6 of them here, 35 here. I could add them and call it 41 square root of 3. That should do it also for this problem. Next, number 8 and number 9. Number 8. Square root of 50 is not like square root of 100 or square root of 400. But 50 has a 25 inside. And 25 is a perfect square. So I'm going to write this as square root of 25, square root of 2, square root of x to the second, and square root of x. That will give me 5 from square root of 25. Square root of 2 is irrational. Square root of x to the second is absolute value of x. Make sure that you know and you keep this in mind. Square root of x to the second is absolute value of x. Don't forget the absolute value. Times square root of x. We cannot do anything about this, just like the square root of 2. We cannot simplify it. Final answer. We could put the square roots together. So we could write 5 absolute value of x square root of 2x. And we're done. So that's the answer for this problem. This was on the side just to highlight or emphasize that this gives you absolute value of x. Number 9. One more time. To subtract this, they need both to speak the same thing. A like term, like square root of 3 here. But I have 2c here, I do have the c. This has to speak 2. Before we start, we could say 72 is 36 times 2. So let's do this on the side, we'll come back to the problem. Square root of 72 is a square root of 36 times 2. Square root of 36 times square root of 2. 6 square root of 2. Back to the problem. So we have 6 square root of 2 square root of c minus 2 square root of 2 square root of c equals 6 square root of 2c minus 2 square root of 2c. We do have the like terms. 6 minus 2 of the same thing. That's a 4 square root of 2c. And we're done with this problem. Number 10. Write radical 3 over radical 5 in simplest form. Of course, this relates to rationalizing the denominator. So we don't need an irrational number like radical 5 in the denominator. The way to do it is we rewrite it, and here we go. Rad 3 over rad 5, and we multiply the top and the bottom side by radical 5 because that's our focus. Now when you multiply down here by radical 5, it's like you are squaring the radical 5, which you get rid of the square root, and this becomes on top radical 3 times radical 5, and down radical 5 to the second, which simplifies to radical 15 over 5. And that should do it for number 10. Number 11, we have 2 over 1 minus radical 7, and we need to rationalize the denominator. So what we do is we multiply the top and the bottom side by 1 plus radical 7. And for this part right here, this looks like a minus b times a plus b, which is the factored form of the difference between two squares. In this case, comparing this to ours, that is a, which is 1, and that is b, which is radical 7, because that's what we have in the front. That's a minus b, and that would be a plus b. To apply this rule, we're going to end up with a squared minus b squared, and that will give me a squared, which is 1 squared, minus b squared, radical 7 squared. On top, we just multiply 2 times. Let's keep it because it's going to simplify with the 2 outside instead of using the distributive. Down below, it is 1 minus 7. One more time, I said let's keep the 2 outside, and you'll see just in a second why. This reduces to 2 times 1 plus radical 7 over negative 6. And if I divide both sides, the top and the bottom side, by negative 2, if you divide this by negative 2 and divide this by negative 2, dividing by 2 because 2 and 6, they both divide by 2, and the negative sign, why I'm divided by negative, because I want to get rid of the negative from the denominator. This will give me 1 times 1 plus radical 7, because the 2 cancels, over, let's see, 2 divided by negative 2 is negative 1. That's a negative 1 times. And negative 6 divided by negative 2 is positive 3, which reduces to negative 1/3 after you distribute the minus 1 and you divide both terms by 3, minus radical 7 over 3. And that should do it. Number 12, we need to rationalize this fraction, 2 over cubic root of 7. Now notice that if you multiply like before in example number 10, when we had it radical 5 at the bottom side, if you multiply top and bottom side by radical 7 or cubic root of 7, cubic root of 7, that's not going to help. The reason why, because if you multiply at the bottom side right here, let's say radical or cubic root of 7 times cubic root of 7, this is like 7 to the power 1/3 times 7 to the power 1/3, which is 7 to the power 2/3. But that's still irrational. So the way to do it, we need to multiply by another cubic root of 7. And if you do that, I get at the bottom side cubic root of 7 times cubic root of 7 times cubic root of 7, which is like 7 to the power 1/3 times 7 to the power 1/3 times 7 to the power 1/3, which reduces to 7 to the power 3/3, which is 7. Just 7. In other words, you need to multiply top and bottom side by 7 to the power 2/3. That's what you need. Because you have 1/3, you need 2/3 to make it happen. Going back to the problem, we could simplify it and write this as on top 2 cubic root of 7 times 7, which is 49, over just 7, what we agreed on. When you multiply the 3 terms right here, you get just 7. Of course, you could write this as 7 to the power 2/3, but that should do it. Number 13. Now we are dealing with 1.4, which is polynomials and factoring. That's going to be introduction to factoring. Multiplying using the FOIL method and some other methods, distributive property and so on. Those formulas, they need to be known. This and this are called perfect square trinomial. Perfect square. On the other side, it's a trinomial, 3 terms. If you have a minus here, it shows right here. If you have a plus, there is no minus that shows up. And this right here is a plus b, a minus b, which we used in the previous page. That comes from the difference of two squares. Number 13. For the following polynomial, identify the degree, the leading term, and the leading coefficient. The degree is right here. This is first. So it's going to be 5. The leading term is -2. Don't forget the negative sign. X to the power 5. And the leading coefficient is the coefficient of the leading term, which is -2. That should do it. Adding polynomials, subtracting polynomials should be something easy, but we have to be careful, especially when we subtract. So let's add these two polynomials. The parentheses are just telling me that I'm adding this polynomial to this polynomial, nothing much. So it's like 4x to the third plus 8x to the second minus x plus a negative 4x to the second and x. That's not going to be minus because we're distributing a plus sign, and a 6. To finish the problem, we're going to combine like terms. This one is the only term that is cubic. This should be combined with this. Notice I circled the plus sign and the minus sign, just to be careful. And this should be combined with this. And the constant 6 stands alone. So we have 4x to the third and the ones circled in red will be 8x to the second, take away 4x to the second, and that is 4x to the second. And the ones underlined in green will cancel. I don't need to mention them. The last number 6 shows up by itself. That should do it. Now let's subtract these two polynomials. This is the main part that you need to be careful about. Distributing the minus sign. So 6x to the second plus 24x plus 24 minus 3x to the second. Subtracting negative 6x will be adding 6x. Subtracting a 3 will be minus 3. Again, we need to combine like terms and we'll be done. These two together, I have them in red already, so while I'm holding the marker, let's go. 6x to the second minus 3x to the second will be positive 3x to the second. Let's go with x's in green. This right here should be combined with this. I do have 24x and 6x. That will make it 30x. Finally, 24 minus 3 is 21. And that should do it. Next, number 16. Let's bring the curves down a little bit. Number 16 is find the product. Well, to find the product, we need to use the formula that says, or the ones were listed for us. That to me looks like a minus b multiplied by a plus b. As you could see, it's the same numbers here and here. That's my a, that's my b, same a and b right here, which gives me a square minus b square, a difference of 2 squares. Applying it, we get the following. That's going to give me a square, that's 9x square, because that's my a, minus b square, which is 11 square. Finally, that's 81 x to the second, because the square is for 9 and x, minus 121. Next, number 17, multiplying this by itself, that is coming from the formula that says a minus b to the second will give you a to the second minus 2ab plus b to the second. Applying it, I get the following. That's a and that's b. A minus b, a is 4x and b is 1. A to the second will be 4x to the second minus twice a multiplied by b plus b to the second. That's 16x to the second minus 8x plus 1, and that should do it. Number 18. 18 for this problem is going to end up multiplying. Same thing we had it before. That's like a plus b multiplied by the same amounts but with a minus, a minus b, and that will give me a square minus b square. So the answer is a square minus b square. A is 5x and b is 2. Answer is 25 x to the second minus 4. Next, number 19. Factor completely. To factor the following, knowing this before, I don't have to try to use parentheses and try to see which numbers multiplies to 36 and such that they add up to negative 12, because I know that it belongs to the rule that says a squared minus 2ab plus b squared is coming from a minus b to the second. So a is x and b is 6 because b to the second is 36. You could try it and we'll double check. So the answer is x minus 6 to the second. Or you could just factor normally. So this right here will give me x minus 6 times x minus 6. The front, x times x, will give me x to the second. The end, the last, will give me negative 6 times negative 6, positive 36. And to get the midterm, you go for the inner ones and the outer ones, and they both give you negative 6x. Negative 6x and negative 6x is negative 12x. So anyway, you could do it. You could write it this way, or you could write it this way. This right here is the other form, which comes from a squared plus 2ab plus b squared comes from a plus b to the second. Notice that 9 is 3 squared, and z squared is a squared, so z is a. 2ab will be 2 times z times 3, which is 6z. So to do this problem quick, we could just write it's z plus 3 to the second. Notice z plus 3 looks like a plus b. We have second. If you square 3 like b squared, you get it 9. And if you square z instead of a, you get z squared. Multiply a times b and double that amount. 3z, double that amount, it's 6z, which is right there. Next, number 21 is about a squared minus 4ab plus b. That is going to be similar to this right here, instead of rewriting it. So the answer, just for more practice, is a minus b, that's b squared, minus b, which is 2. I was going to write 4 to the second. And you could double check. A minus 2 times a minus 2, that's the same thing. Negative 2 times negative 2 is 4. A times a is a to the second. Minus 2a and another minus 2a is minus 4a. That's the difference of two squares, which is x to the second minus 5 to the second. Using the formula for the difference between two squares, that's going to give you a minus b times a plus b. So it's x minus 5 and x plus 5. Again, we're done with this problem. 49 x squared minus 4y squared, number 23. That's the difference of two squares. If you don't see it, let's look at it this way. 7x to the second minus 2y to the second. Now it looks like a squared minus b squared. And the answer will be a minus b times a plus b. That's my a, and that's my b. This is a sum of two cubes. If you don't see it, well, actually, sorry, I went too fast. Let's factor the 10 out, because 10 is not part of a number that is cubed. It's not. 82. So let's take 10 out as a common factor first. Sometimes we do this to get to the problem and solve it. Leaving 10 in my way in 80 is not going to work. So we have x to the third from the first term, and 10 times what will give me 80? That's 8. Now that's a sum of two cubes. You could tell that I went too fast. To do this problem, we could refer to the formula, and the formula is the following. Let me write it down here. A cube plus b cube equals, there's a short one and there's a long one. That's how I call it to memorize it. A plus B, A square plus AB, not 2AB like before, and B square. Applying it to our problem, we have 10 already out. This right here, think about it as x to the third plus 2 to the third. So that's a sum of 2 cubes, which is going to end up 10 times a short one and a long one. Short one will be x plus 2, so it's just a and b. A square x to the second. AB, as I said, not 2ab, will be 2x, x times 2, that's 2x, and 4. I do have a mistake right here. I went too fast. That should be fixed before I go on. I'm not going to look for whiteout. Let's do it right here. The formula, you do have a minus sign somewhere. The minus will show up right here. If it doesn't have a minus, it shows right there. That's a minus. So to fix the problem, that should be a minus. Okay? Just think about it. The other form, I'll mention it, so you could memorize both right here. Well, actually, I'm looking ahead, trying to save you some time. That's the minus one. So I'm going to write it anyway for the coming problem. For this problem right here, I'll write the cubic so I could save some room and refer to this. If you have a cube minus b cube, you do have a short one and a long one. But the difference between this form and this form is the minus shows right away. So we have a minus b, and now we have a square plus ab plus b square. So one more time, this will have the minus right here because the formula has a minus, but on the long one right there. That should do it. So let's apply this form right here after seeing it as cubic. To see it as cubic and difference between two cubes, that's 2x to the third altogether minus 1 to the third. I see the difference between two cubes. To finish the problem, we're going to say a short one and a long one. So we have 2x minus, we show the minus first, and we have a square, that's going to be 4x to the second because a is 2x, and all pluses plus a times b, 2x times 1, which is just 2x, b square is just 1 square, which is just 1. That should do it. So this right here is a difference of 2 squares. If you don't see it, let's write it down as a different, as being squares and a difference between 2 squares. So this could be looked at 2 times a all square, which gives me 4a square minus 3b square. Now I could see the difference between 2 squares, which gives me 1 with minus, 1 with plus, it doesn't matter which one first, 2a, 3b, 2a, 3b. That should do it. Next. Number 27. To factor this, we are looking at factor by grouping, or you could do it normal factoring. this 5x, I need to split the 5x into two terms such that the coefficients will add up to 5, but they multiply to 2 times 3, which is 6. And that will be 3x plus 2x. That is the midterm. Now it's two terms. Bring the 3x to the second. Bring the 2 down. Now, when we call it factor by grouping, we're looking at this 2 together, and we're looking at these 2 together. From here, we could factor 3 out as a common factor, and also one more x. So I do have x from the first term, and from the second term, just 1. And 2x plus 2, they will have a common factor 2, and I have x from the first term, and 2 times what will take me back to 2? That's 1. Now, you notice now the magic, which is both terms, they do have x plus 1. So let's take x plus 1 out from the right. And from this right here, if we take this out, we have 3x. From this right here, if we take x plus 1 out, we have 2. And that should do it. Okay? Now, of course, you don't have to do it with grouping if you could manage. What do I mean by this? You just start by doing it this way. 3x to the second, there is only one option, 3x and x. Since it's all positive, I'm not thinking about negatives. 2 will be 2 times 1 or 1 times 2. If you put the 2 here and the 1 here, that's going to work. If you do it the other way around, it's not going to work. If you put the 2 and 1, it's going to work. Let's try the other way to show that's not going to work. 1 here and 2 here. Well, I know that this works. 1 times 2 is 2. X times 3x is 3x to the second. But look at the midterm. The inner ones will give you 1x, and this will give you 2 times 3, which is 6. 6 and 1 is not going to give me 5. So I have to switch them and make it 2 and 1. And you could tell by double check. I'm not going to check right here. I'll do it right here. Take a look. N will give 2x. Out, 3x times 1 is 3x. If you add them up, you get what? 5x. That's 5x. This right here is factor by grouping. I could see it clearly. This goes together, and these two, they go together. From the first term, I could take 2 out. 2 and 4 will give me a 2. That has an x. This doesn't have an x. Looking at the y to the second, they both have y to the second. We'll take it out. And I do have from the first term x, from the second term 2, to take me back to 4. For the second part, let's use green. Both could give me 5 as a common factor. 5 times what will give me 5x? 5 times x. Excuse me. And 5 times 2 will give me back 10. But again, something happens here, which is x plus 2. It's a common factor. We'll take it out from the right side. And from the first term, we get 2y to the second. And from the second term, we get 5. And that should do it. We're done. Okay? Let's move down to number 29. 29. To simplify the following, it's not going to take time. I did not leave room for it. There's no need. That is a plus 1. Down here, it's going to factor. Well, once you get something like that, it's kind of like you do have a hint that something is going to happen, so you could cancel. So I'm assuming that a plus 1 is going to show up. Well, it does, because 1 times what will give me 3, that's a 3. A times what will give me a square, that's a. And all pluses. Double check, that's a 3a, that's 1a, which is 4a. Now we could cancel this by dividing top side by a plus 1 and the bottom side by a plus 1. Of course, assuming that a is not equal to -1, because we cannot do this if a equals -1. Because if a is equal to -1, this is 0. Okay, we can't divide this by 0 and divide this by 0 to cancel them. Something to keep in mind. This will be mainly for the coming sections when we start graphing and talking about the domain restrictions. So the final answer is 1 over a plus 3 such that a is not equal to -1. Okay? If somebody asks you about the domain, of course the domain does not have a -1 and does not have a -3. Okay? But the behavior at those two locations is something for coming sections. Now let's factor this. This will take more room. As you can see, I gave it more room than the first one. And let's do our best. Top side for the first one. That's going to be 4b times 1b. 4b times b is 4b to the second. And to get 2, it's going to be 2 times 1 or 1 times 2. By trying back and forth or using any other method, 2 has to go here and 1 has to go here. 2 times 1 is 2. 4b times b is 4b squared. 1b and 8b, I need to end up with 7b. So the minus has to go somewhere. I'll give the minus to the 1. So I could say I do have 8b, take away 1b, which is 7b. That's a difference of 2 squares. So it's 1 minus b times 1 plus b. Next, factoring the following right here. This right here is b and b, 1 and 1, minus and minus to end up with a positive 1, but a minus b and 1 minus b, again, that's minus 2b, which is like b minus 1 altogether to the second. Down below, to factor it, I'm gonna go 4b and b to end up with 4b to the second. 4, I do have options, 4 times 1, 2 times 2, or 1 times 4. Makes a difference because there is a 4 here. By trying back and forth, it will end up 1 here and 4 here. So that will give me the 4, but take a look at the 15. 1b, 4 times 4, 16b. Somehow 16b and 1b will give me 15. I need to end up with 16b, take away 1b to make it 15. Now imagine if this all is one fraction and all these factors are on top and bottom side. We start cancelling with the concept that when we do it, we keep this in mind, this concept. Let's just keep going and simplify to the best that we can. This cancels that as long as b is not 1 over 4. And what else we have? We have, this is interesting in this problem. b minus 1, 1 minus b are about the same. But if you look at it, b minus 1 over 1 minus b, it looks like they got switched. Well, how about if I take b minus 1 on top, if I do it, and I multiply it by -1. To do that, that's going to end up minus b, minus 1 times -1, which is plus 1, or differently 1 minus b. So what's 1 minus b and b minus 1? They are opposites. So if you take the opposite of this, you end up with this. Meaning when you cancel this and this, you get -1. Something to keep in mind. It doesn't happen often, but it's good to be aware. So what do we have? We have a minus sign, b plus b times b minus 1, b plus 2, I mean, I don't know what I said here, b minus 1 over 1 plus b and b plus 4. That should do it. Of course, the conditions that you can't have b equals to 1 when you eliminate those, and you can't have b equals 1/4. That causes this to be 0. Number 31. Is to factor this to be able to simplify. Top part will be x and x. We have 2 and 1, but we need to end up with positive 2. So I'll give the positive to the 2. This way I have take away 1x and 2x, that's positive 1x. That's the difference of 2 squares, 1 minus x and 1 plus x. One more time, just to emphasize what we had earlier. These two cancel, but knowing that x minus 1 is the opposite of 1 minus x. And we could do that as long as x does not equal to 1. So what's the final answer? It's a minus 1 multiplied by x plus 2 over 1 plus x. Or differently, we could say minus x minus 2 over 1 minus x. 1 plus x. That's a plus right here. That should do it. Section 2.1, solving linear equations in one variable. When you solve right here, it says classify the following equation as conditional, or identity, or contradiction. Now, we want x only on one side, so I'm going to go over 2x and cancel it, and that's the way to do it. And we end up with 8 on the right, 5x minus 2x, 3x plus 1. Then we subtract 1, and I end up with 3x equals 7. So let's write it in a clean way. That's what we have. Divide both sides by 3. And I end up with x equals 7 over 3. It's one solution, and that is called conditional. Second one. Notice that we have the same slope, different y-intercepts. So if you graph it, 2x plus 1 is going to go this way, crossing the y-axis at 1. And that has the same slope, but crossing below. They're not going to intersect. There is no solution. But let's say you want to start solving. You subtract 2x from both sides, and look what happens. You end up with 1 equals -1. Of course, you cannot accept that. And that's an indicator that we have no solution. And to classify it, we call it contradiction. Okay. Last one. Kind of lengthy, so you don't see it clearly like that, and you start attempting to solve. I get 3x plus 2x plus 1x, which is 6x, plus 5, simplifying before I move on. That is 6x plus 1 and 4, which makes it 5. Look what happens. They're both the same, identical, 6x plus 5 and 6x plus 5. That's why you couldn't see it here. But once you see something like that and you start solving, subtracting 5, and then subtract 6x, you end up with 0 equals 0. That means all real numbers. All real numbers. That's the solution. And we call this identity. Okay, that should do it. Number 35. Slope of a line. Use the slopes to determine if the lines are parallel, perpendicular, or neither. 7x plus 2y, 2x plus 7y. At first it's hard to see quickly what's the slope. They look almost the same, but they're not. So for this one to solve and find the slope, that's one way to do it. You could subtract 7x from both sides to write it as slope-intercept form, and you end up with 2y equals negative 7x. Of course, you can't combine these ones. Some students do because they're kind of like lined up and you're forced to subtract them, but you can't. They're not like terms. You just have to write them next to each other. Divide by 2, divide by 2, divide by 2. And that gives you y equal negative 7 over 2 x plus 3 over 2. So the slope, let's call it m1 for y1, equals negative 7 over 2. Let's go to the second problem. Notice that you don't have to do all this if you could see what happens. This is like ax plus by equals c. You're going to move ax to the side. It's going to show as minus ax. And you're going to focus on the slope now. Divide by 2, which is b. And you end up with minus a over b. That's the slope of standard form. So moving this, then dividing by 7, the slope should end up negative 2 over 7. So what do you think about the slopes? They're not opposite reciprocals. They're only reciprocals. The slope right here and the slope right here are almost identical. They look like each other, but not. So it's not parallel and it's not perpendicular. It's not parallel or perpendicular, it's neither. I have an example of each case. Let's look at part P. This right here will say m1 equals 5. This right here, I have to remove this to the other side. m2 is 5. It changes to positive. So now we are looking at parallel lines. Same slope. Third one. m1 for the first line. L1 is 4. m2 after you move this and then divide by 4 will give you negative because we moved it, and then I have to divide by 4, so it's negative 1. That's 1x, gives me 1 on top, over 4. Now 4 is like 4 over 1. That's reciprocal of this, and that's the opposite of this. So we do have what we call in math that m1 times m2 are opposite reciprocals, but if you multiply them, you get 4 over 1 times negative 1 over 4, which is negative 1. So we call that perpendicular. Done. Number 36. Find the equation of a line. To find the equation of this line, knowing that the slope is negative 1/3 and contains the point 6, negative 4. They want it in slope-intercept form, so we have y equal mx plus b. Y equal, instead of m, I'm going to write negative 1/3. X plus b. I'm going to use this point to find b. So let's do that. We'll write here 6. And we'll write here for y negative 4. And we'll try to finish it. So I have negative 1/3 multiplied by 6, which is like 6 over 1. plus b, we don't know b yet. Simplifying that, dividing by 3, 1, dividing by 3, 2. Don't forget the minus sign in your way. So I do have negative 4 on the left, negative 1 times 2 over 1, that's negative 2, plus b, add 2 to both sides to solve for b, and b equals negative 2. If they want slope-intercept form, we write it as y equal negative 1/3 plus, x minus 2 for b. And if you want to do it as point slope form, that's a quick one. We use the form y minus y1 equals m times x minus x1. Now it's y minus, that's my y1, minus negative 4. Let's make it positive 4, because y1 is negative, equals negative 1/3 times x minus x1, which is 6. So we have the two forms, point slope form and slope intercept form. Sometimes you might be given 2 points to find the equation, both forms, point slope form and slope intercept form. Let's start with this one first. I need to find the slope, so this one will take longer because I don't have the slope. But if I write the points lined up, I could find the slope this way. We have negative 2, negative 4 as my second point. That's like x2 and y2. And I have the point 1, negative 3 beneath it as it's x1 and y1. To find the slope, we could use the formula y2 minus y1, that's the rise, over x2 minus x1, and that will give me y2 minus y1, as you could see. Let's use parentheses to be on the safe side. As you could see, I have too many negatives, just to be careful. To make it distinguished, I'll use different color right here. So y2 is negative 4 minus y1, which is negative 3, over x2, which is negative 2, minus x1, which is 1. Simplifying, we have negative 4 plus 3 over negative 2 minus 1, and that is negative 1 over negative 3, which is positive 1/3. Now we have the slope. So this becomes like another practice compared to the previous problem. To write the point slope form, you could use either point, it doesn't matter. So I'm not going to use both to save you some time. I'll just use maybe the first one. Let's use this one. So I'll keep this in black for the point slope form. Y minus y1, that's my y1. I call it y1 now because that doesn't match this one, but I just picked it already. Y minus negative 4, it's going to be plus 4, equals m, which is 1/3. And this is my x1 for this problem, or the first coordinate, x minus negative 2, which is plus 2. Either form or either point will do the same job. I know it might look different, but trust me, it's going to give you the same graph if you simplify it. Now to write the slope-intercept form, I could use the previous method and plug in a point to find b, just like this, or I could go from here and simplify it and find b by simplifying. So let's do that. So I have y plus 4 equals 1/3 times x plus 1/3 times 2, that's 2/3. Subtracting 4 from both sides to leave y alone, because that's the slope-intercept form. We get y equal 1/3 x plus 2/3 minus 4. I need to combine these numbers. To do it, let's do it and save some time right here. Think about this as over 1. Multiply this by 3 to have the same denominator, and we'll finish it. So I have y equal 1/3 x plus 2/3 minus 4 times 3, which is 12/3. That will give me minus 10/3. So the other form is y equal 1/3 x minus 10/3. So that's one form, slope-intercept form, and that's the other form, which is point-slope form. (38). Let's start with part A. Determine the slope of the line, this line, by moving the negative 3x to the other side and dividing by 4. I get 4y equals 3x moved to the other side, or you could say add 3x plus 8, divide by 4, divide by 4, divide by 4. That's going to end up y equals 3/4 x plus 8/4, which is 2. They say find the slope. So the slope is 3/4. Second part, part B, find the equation of the line containing the 0.14 that is parallel to L. Well, if it's parallel to L, it will have the same slope. So M should be also 3/4. We've done similar question, but let's do it again. They didn't say which form, so I'll use the slope-intercept form. Y equal 3/4 x plus b. To find b, I'm going to use 1 for x and 4 for y. So that will end up 3/4 multiplied by 1, because x is 1, plus b. To solve this, you could do it different ways, but I could see that b by itself equals, when you subtract 3/4 from both sides, 4 minus 3/4. Doing it mental math, you could say it's 1 and 1/4. Or you could use common denominator. The common denominator will be 4, so that's like 16/4, same thing like 4, minus 3/4, which is 13. 16 minus 3, which is times 4 times 4, 16 minus 3, which is, I'm thinking about what happened here if I made a mistake. 13/4. That should do it. So y equal 3/4 x, that's my slope, plus 13/4. All right, that should do it. The second one is asking for if I need a line not parallel to but this time perpendicular to L, going through 1, 4. Well, if the slope was given to me, or the one that we found was 3/4, for a line that is perpendicular, let's call this one M1, M2 will be opposite reciprocal, so it's -4/3. They didn't say which form to use, so we could use either one. Let's use the point slope form. Y minus y1 equals m times x minus x1. Y minus 4 equals, my new slope for the perpendicular line is -4/3 times x minus x1, which is 1. And that should do it. It's a quicker one. We tried both, so that should be fine. Unless if they say write it in slope-intercept form, we have to do it that form. Number 39. We're getting close. 2.5 quadratic equations. Solve each of the following quadratic equations by completing the square. Since this is 1, we do the following. We look right here, and this is what I usually say. And I know it's a lengthy video, so that's why I'm not making any jokes or going off. But every time I write look, I think about the comment that came one time from a student that was not paying full attention or missed it, let's say, and then came back to me and asked me, why did you write 100K? Looks like 100K, right? So it just look. Then after that, I started making eyes that you're looking at it. Okay? So what do you do with the 4 after you look at it? You take it to the side, you take half of it, and then, which is 2, then you take that, square it. But ends up 4 in this case, which is fine. You go back to the problem, and you do the following. X to the second plus 4x equals -21. I gave it some room right here. And now I'm going to bring this 4 to both sides. Let's use red to show you where it came from. That's this 4. So you bring 4 to both sides. And what happens is some magic happens. The left-hand side is a perfect square. And it reminds me of the following. That a square plus 2ab plus b square, if you factor it, goes to a plus b to the second. So it's almost like if you have this, you want to take it to this, you just look here and look here and bring it down to a and b. That's my a square, that's my b square. So the answer is on the left. This goes down to 2, this goes down to x. And the right hand side is -21 plus 4, which is -17. It says solve, so we're not done. Take the square root of both sides. You get x plus 2 equals plus minus square root of -17. The negative inside the square root will give you an I imaginary number, because that's like plus minus square root of -1 square root of 17, where this one is equal to I imaginary number. So what's the final answer? The final answer is x equal, subtract 2 from both sides, you get -2 on the other side, plus minus square root of 17 I. Don't write the I next to the 17 because sometimes it's misleading, like it looks like it's inside. That should do it. Number 40. To solve the following by completing the square, that takes a process. What do I mean? You need to take the 3 out before you say, look here. You don't take 2 to the side and take half of it. So let's try to finish it in a clean way. 3 outside, x to the second, plus, how do you take 3 from here? You're forced to take it, so you have to adjust it back and write 2/3 x. Look, 3 times 2 over 3x, 3 cancels, and takes you back to 2x. I'm doing like 2 steps in one. and I'm moving the 4 to the other side. Now you look here. This is where you look. And those are i's, so it's not 100k. Take 2/3 to the side. Divide that by 2. Kind of hard to write it over 2 this way. So I'm gonna take my time and show you the steps. That's times 1/2. You change division to multiplication and you flip this. 2 cancels and you end up with 1/3. Once you're done, what do? You square it. And that's 1/9. So that's what you bring to both sides. Let's bring it back, maybe with black, to show you that was not part of the problem. I'm trying to not to fill the whole page and make it less writing. So I'm doing 2 steps in 1. Now you might go too fast here and add 1/9. It's not true, because 3 is multiplied by 1/9. 3 is multiplied by x to the second. It looks like you're adding 1/9, but you're not. You're actually adding 3 multiplied by 1/9. So what's 3 times 1/9? That's like over 1, which is 1/3. So that's what you are adding. You add 1/3. Trust me, if you multiply this, that's going to look like 3x to the second plus 2x plus 1/3. So you're coming in with 1/3. So you have to add 1/3 to the other side. 4 and 1/3, also another way to add fractions. You make this over 3. So you multiply by 3 by 3. That's 3 times 4, 12. 12/3 plus 1/3 is 13/3. Okay, let's move on. So we have 3. This right here will be like a perfect square trinomial, or the trinomial that comes from a perfect square. That's why we completed the square. And we have x to the second goes down to x. Pluses will take a plus. 1/9 comes down to 1/3. That here, as I said, it's 12/3, which is 4. Added to 1/3, that's 13/3. Finishing the problem, I'm gonna divide both sides by 3 to leave this alone, or differently, I'm gonna say multiply this and multiply this by 1/3. Multiply both sides by 1/3 to cancel this right here. So when it cancels, you end up with x plus 1/3 to the second equals 13/9. Take the square root of both sides and get x plus 1/3 equals plus minus square root of 13 over square root of 9. Let's apply the square root to both. The top side stays. The bottom side, square root of 9 is 3. We're almost done. By moving the 1/3 to the other side, I have the answer. Instead of zooming out, I'll just keep it here. That will give me x equal negative 1/3 plus minus square root of 13 over 3. That should do it. Okay. We finished 40. Let's go down to number 41. Determine the number and type of solutions to the following. That means you need to look after the discriminant. So thinking about this as ax to the second plus bx plus c equals 0. A is 9, b is negative 6, and c is 1. B squared minus 4ac is the following. B is negative 6. A is 9 and C is 1. Finishing the problem, that is equal to 36 minus 4A times C. 4 times A, which is 9, times C, which is 1. That's minus 36. 36, which is 0. So if it's 0, we say one real solutions or solution. Now, in some cases, if b squared minus 4ac, which is called the discriminant, is greater than 0, we have two solutions. If b squared minus 4ac equals 0, we have one solution, which is called repeated solution. And if b squared minus 4ac is negative, we say two complex solutions. 42. To solve the following, I need to cancel this and leave x alone. So I'm going to raise both sides to 4/3. Why? Because when you apply the exponents right here, it ends up 12/12, which is 1. We have a rule in math that says a to the power m to the power n is a to the power mn. And that's what cancels it or makes it 1 times its reciprocal. So let's go back to the problem. Left side becomes x. Right side is 27 to the power 4/3, which is 27 to the power 1/3 all to the power 4. And that's cubic root. That's the same thing as cubic root of 27 all to the power 4. The cubic root of 27 is 3. 3 times 3 is 9, times 3 is 27. So it's like 3 to the 4. And the answer is 81. That should do it. Number 43. Here we need to clean it up first before we square both sides. So I do have to add 5 to both sides. And I get here square root of 5x plus 1 equals 4. Take the square root of both sides. Square both sides. Let's do that right here. And if you do that, you get 5x plus 1 equals 16. Subtract 1, subtract 1. That will give you 5x equals 15. Divide by 5, or mental math, x equals 3. 5 times 3 is 15. That should do it. Number 43. Actually 44. The one that we finished was 43. So 44, when you have an absolute value, just remember that absolute value means distance from 0. For example, the numbers that they have a distance from 0 with 5 units, that should be x equals 5 or x equals -5. So we're going to apply the same method right here. That says that I do have 6x plus 4 equals 8 or 6x plus 4 equals -8. Let's close this right here, out of my way. So we could work on both at the same time because the steps are identical. Subtract 4, subtract 4, subtract 4, subtract 4. 6x equals 4. 6x equals -12. Divide by 6, divide by 6, divide by 6, divide by 6. x equals 4 over 6, which reduces to 2/3. Or, let's bring the or down. 6 cancels, negative 12 over 6, which is negative 2. And now we have two answers. You could double check and it should be fine. I'm not gonna check now and take more time and make it a longer video than what I'm expecting. 45. Linear inequalities and absolute value inequalities. To solve this, that's a simple step. Just by adding 15. So I have x less than 19, and we're done. Here, we're going to subtract 1. When you subtract 1 or add, we keep, we don't flip the inequality. 6 minus 1 is 5, and minus x goes down. Now, this is what happens that I need to make sure that you see it all clear. Divide both sides by negative 1 or multiply both sides by negative 1 to leave x alone as positive 1x. 5 over negative 1 is negative 5. But make sure that you get this part and you flip the inequality sign. So it's going to be, instead of this form, it's going to look like this. So you could rewrite it, but you don't have to. We read it as x greater than or equal to negative 5. X is greater, instead of saying minus 5 less than or equal to x. So that should do it. So whenever you divide by negative, you need to flip the inequality sign. That's something that you need to keep in mind to avoid mistakes. The more that you know where the mistakes happens, the more that you're going to do well and score higher on exams. We need x on one side. I need to cancel either the 2x or the minus x. I always go after the lower one to end up with positive x's, not negative. We try to avoid as much as we can, ending with more negative terms. Left side will give me 1. So when we add, we don't flip. That's a 3x plus 7. This is a simple math. We're going to subtract 7 from both sides, then divide by 3. So subtract 7. When you subtract 7 from both sides, you don't flip. 3x by itself, that's a minus 6. Then we're going to divide by 3. And when you divide by 3, you don't flip it. So you end up with x on this side less than stays the same look, because I'm reading it as x less than. I know it looks by itself as greater than, but, or you could say x less than negative 2. So we did not flip it. I just switched these ones to read it correctly. We did not flip it. When you have an example like this, to practice more, I'm going to go after the smaller one. I'm going to add 7x to both sides. This cancels. We're going to keep the inequality symbol. That's a 17x minus 4, and that is a 13. Add 4 to both sides. Add 4 to both sides. And you get 17x. 13 plus 4, which is 17. Divide by 1. We don't flip it. Divide by 1. Keep the inequality. I say divide by 1. I'm trying to go fast. Divide by 17. Divide by 17. I'm thinking ahead. That's the one that I was having in mind. So it's x less than or equal to 1. Done. 2 more questions and we are done. Inequalities with absolute value. Whenever it's less, I call it n. So you need to be careful about these two problems. What do I mean? I mean x minus 1 is less than or equal to 3, greater than or equal to negative 3. That's how we translate that to inequality. And finish. Add 1 to all sides. We don't say add 1 to both sides. All sides or 3 sides. And when we add, we don't flip. And now we have x on the side by itself. That's a 4, and that's a negative 2. What do I mean by n? You think about it this way. Here's a 4, here's a negative 2 on the number line. They're both included. And that's when we say and combine them. That's the solution as a graph. As an interval notation, bracket, negative 2, 4, bracket, including negative 2 and including 4. Last problem. When you have a distance from 1 more than 3, that means you're going out on both sides. To do this problem, you have to say x minus 1 greater than 3, or. That's how we start with or. I'm writing it in big letters. I'm trying to emphasize that this is how it works. You use or. X minus 1 less than negative 3. Finishing the problem, that's plus 1 plus 1 plus 1 plus 1. Cancels, cancels. And when we do this, we don't flip the inequality sign. We end up with x greater than 4 or x less than negative 2. If you want to graph it, 4 is somewhere here, negative 2 is somewhere here, and now we are going less than negative 2, greater than 4. That's why we use or. We can't be here and here. Either you're here or here. Now, we're done with the 50 questions, but this also could be done without these steps. Let me show you. It's a quick comment. Distance away from 1 by 3 units. So here's 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4. Let's stop right there. When you are away from 1 by more than 3 units, that's 1 unit, 2 units, 3 units. So you are here. Or on the other side as a distance, 1 unit, 2 units, 3 units, you are here. Same answer. It's just a comment about understanding it from the point of view as distance from 1 on the number line being greater than 3 units. The graph says it, and if you mark 1, 1 is going to be right here. You are 3 units on the side more, or 3 units on the side more than, as a distance of 3 units from 1. That should do it. I know it's a lengthy video, but I think it's worth it. It's a lot of ideas, a lot of concepts in one video. Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.